Hi everyone. So the next couple of days we're going to look at something called gas laws. And before we begin, you have to remember back to what we did in section 1 about gases. Remember, gases, there's no force of attraction between the particles, and the gas particles are spread out very far, okay? The other thing you want to know is about pressure. So because there is no force of attraction holding these gas particles together, they're going to basically be zipping around wherever they want, okay? So when you are looking at a car tire, what happens is the gas particles inside this tire are zipping around, hitting the sides and the top of the tire. And the pressure that they feel as they go against the walls of the tire basically keep the tire inflated. One way I kind of demonstrate pressure in class is I'd have a student hold up a textbook and then I will punch the textbook. That student will feel that force, right, because I've punched the one side. Well, that's kind of what pressure is. Those gas particles constantly hit the walls of the tire and then that keeps it inflated. Now, what's important about pressure is it doesn't matter the type of gas that you use. Again, if we look at this tire, I could fill this tire with air, which is what you normally would do. We could fill it with nitrogen gas. We could fill it with helium gas, chlorine gas, bromine gas. Doesn't matter what type of gas is in this. As long as it doesn't react with the rubber in the tire, I could fill and inflate my gas tire, okay? Now, the pressure to fill this on my truck tire is 35 PSI, which is pounds per square inch. Now, let's say to get the 35 PSI, let's pretend I need to put 1 mole of gas into the tire. So if I put 1 mole of hydrogen gas into the tire, how many hydrogen molecules would I have in this tire? Well, I would have 6.02 times 10 to the 23rd hydrogen molecules in this tire. If I filled it with 1 mole of carbon dioxide, how many carbon dioxide molecules would I have? Well, again, I would have 6.02 times 10 to the 23rd in there. If I filled it with 1 mole of air, which is a combination of gases, how many mole of air particles would I have in there? Again, I would have 6.02 times 10 to the 23rd. So it doesn't matter the type of gas. What matters is the amount of gas. If I put in 6.02 times 10 to the 23rd of any gas into my car tire, it'll be fully inflated. So what we're going to be doing is we're going to be looking at particular gas laws: Charles law, Boyle's law, Gay-Lussac's law, combined gas law, ideal gas law. And scientists back in the 1800s decided to do a bunch of studies on the gases. And what they quickly realized is it didn't matter the type of gas, it just mattered on as long as you had a gas. So we're going to be looking at the relationship between pressure and volume, volume and temperature, volume and number of moles, and things of that nature. Okay, so you're going to be looking at a bunch of videos from Tyler DeWitt to help explain it. If you still don't understand it, you might want to look for Bozeman Science and see if he did some videos on it as well. The last thing before we get going on this is I do want you to know that you don't see gas laws a lot in grade 12 chemistry, pretty much at the very beginning, and then after that you're not going to see them again. You will see them again in first year university chemistry. Okay? Good luck.